So today you all are going to learn a different type of factoring. So remember, the rest of this chapter is all about factoring. So what we're doing the opposite of today is we're doing the opposite of what FOILing is, multiplying two binomials. All right, so let's remember what we did when we FOILed. All right, so remember, you can pause the video anytime if you need to catch up or hear something again. All right, now I want you to remember FOILing when we did it with conjugates. Remember, conjugates are binomials that differ only in the sign in the middle. So for example, if I have x plus 5, it would be x minus 5. Okay, let's see what happens when we multiply conjugates out. You've got first, outer, inner, last. So you've got x squared minus 5x plus 5x minus 25. So remember, when you have conjugates, when you're simplifying, your two middle terms will always cancel out and you'll be left with the first and the last. So the final answer would be x squared minus 25. Okay, so we already know how to FOIL. What we're doing today is factoring. Factoring is when you write something as a product. So instead of me giving you this as a problem, I'm going to be giving you this, and you need to turn it into this. Okay? This right here is called a difference of squares. A difference because you have a minus in between, and squares means you have two values that are perfect squares. X squared, you can take the square root of it. It would be x. 25, you can take the square root. It would be a 5. These are perfect squares. You have the difference of two perfect squares. So instead of me giving you two binomials to FOIL, I'm going to give you the answer to it, and you need to tell me what two binomials got FOILed. What you need to recognize is when you have a difference of squares. Okay? The square root of x squared is x. The square root of 25 is 5. You use those as the two terms inside your parentheses. You make one a plus, one a minus. So today you all are learning a shortcut to some of the factoring that we're going to do. So here's a rule that you've got. Okay, let's talk about the multiplying rule. If you are multiplying conjugates, okay, there's an example of two conjugates. You can go through the entire FOIL process, first, outer, inner, last, but the shortcut is take the first term and square it, and then take the last term and square it, and it will always be a minus in between. So your shortcut would be take the a and square it, take the b and square it, and it's a subtraction in between. So in homework today, you can practice that shortcut, but when in doubt, FOIL it out. Go through all FOIL steps. Okay. So now let's talk more about starting with this and turning it into this. This is the factored form of this polynomial right here. Okay. So let's talk about, if I want to factor this, I want to write it as a product and make it look like this. So we're going to factor a difference of squares. So you all are learning the special factoring, the ones that have a shortcut. Remember, factoring means write it as a product. When you factor something, you want to write it as a product. Okay, let's say we have 9h squared minus 64. First of all, you need to recognize that as a binomial, and that it's a binomial with a minus sign. So there's your difference. And if you can take the square root of everybody, you have a difference of squares. If you've got a difference of squares, that's where you can take this shortcut with factoring it. You're going to have two binomials, and inside are going to be the square roots. So if you look here, this is a difference of squares. If you take the square root of each, that's x and that's 5. That's what goes in your parentheses. But one will be a plus and one will be a minus. I can take the square root of everybody here. The square root of 9 is 3, and the square root of h squared is h. So those will go in the first two spots. One's a plus, one's a minus. The square root of 64 is 8. That will go in the second spot. If you were to FOIL this out, you would end up getting this polynomial. So here's a shortcut rule. If you see you have a binomial with a minus, and you can take the square root of each term, that's quick factoring. Two sets of parentheses. Square root of the first term goes in spot 1 and spot 2, first place. One's a plus, one's a minus. Square root of the second term will fill in the second spot. That's how you factor it. This is what we're going to focus on today. We'll get a little bit more creative, though, with our examples. All right, we definitely want to remember that rule. All right, let's say I give you all right, so let's start by multiplying it out. Then we'll turn around and do factoring. But there's a shortcut to this. You can do the 4 steps, FOIL, first, outer, inner, last, or you can practice the shortcut if you recognize they are conjugates. So remember, what you do is you take that first term, 4x, and you square it. So think about what that would be. 16 with your x squared. Take your last term, 5y, square it. When you do that, you get 25 y squared. There will be a minus in between. If you were to take all the steps to FOIL that out, your two middle terms would cancel out. So we're going straight to the first and last. Because with conjugates, outers and inners are going to cancel each other out. But again, when in doubt, FOIL it out. All right, let's go in the other direction. Let's factor. So we're going to unfoil it. Let's see what it looked like before we foiled it. Okay, that is a difference of squares. If it's a difference, a subtraction, and you can take the square root of everybody with your two terms, you have a difference of squares. And that's where you know that two conjugates got FOILed in order to get that. So to factor it, you write it as a product, and all you do is you take the square root of the first term, that would be 2c. That would go in the first two spots. Then the square root of the last term, which would be a 9, that would fill in the next spots. One would be a plus, one would be a minus. It does not matter what order you put the plus and minus in. You can FOIL that out to make sure it matches this right here. So I want to do some more factoring examples. Now remember, this lesson is focusing on finding a difference of squares. Well, we have a difference, but I cannot take the square root of those terms. So now we need to go back and think about the factoring we've done so far. We've done GCF factoring. Let's see if there's a GCF that we can factor out of this. Between a 27 and a 12, they have a 3 in common. They both have an a in common. You choose the one with the smaller power, so a to the first. And they both have a b in common. They're both identical, so that's what you use. That is always the first thing you do in factoring. If there's a GCF, factor that GCF out first. So now it's like we're doing the distributive property backwards. We have 3ab, and think, 3 times 9 gets us a 27. A times a squared would get us the a cubed. And we don't need a b because it already has the b. Bring down the minus. 3 times 4 will get us 12. The a is a match and the b is a match. If you were to distribute this, you would match the original problem. You need to be fully factored. So that's one step. But if you look at what you've done, you have now created a difference of squares. You couldn't see it in the original problem. This is like we're doing a factor tree. We broke it down, but we can go further now with this one. The tree can continue. So the 3ab is done. Okay, so our second step, factor the difference of squares that you just created. That's this right here. You're going to create conjugates. 2 binomials that look the same, but one's a plus, one's a minus. What you do to fill it in is take the square roots of everybody. Square root here, 3a, and that goes in both of the first spots. Square root of 4 is 2. Remember, one's a plus, one's a minus. This would be your final factored answer. Let's do one last one to make sure we understand the difference of squares with factoring. All right, what if I give you that binomial? It's a difference. We have a minus sign. And remember, you can take the square root of x to the 8th. When they are exponents, you take half of it. So remember, the square root of x to the 8th would be x to the 4th. So that is a perfect square. And you can take the square root of 1, which is 1. So if we're doing a factor tree, the square root would be x to the 4th. The square root of 1 would be 1. That would fill in the next spots. 1's a plus, 1's a minus. But you need to look and see if you can still factor anything. Right here, check out the one with the minus. Again, you can take the square root of x to the 4th. Take half of that. That's 2. And you can always take the square root of 1. This one's done. Bring it down. Okay, you can't factor it with a plus, only with a minus. This one can break down into 2 more. You created a difference of squares when you factored that original problem. You created another difference of squares. So you go through the process again. The square root of x to the 4th would be x squared. The square root of 1 is 1. 1's a plus, 1's a minus. And then you think you're done. This is done, but look at what you just created. It's another difference, and again, I can take the square root of each. This is another difference of squares. So you keep on going. Bring these 2 down. They're finished. This breaks down into 2 more sets of parentheses. The square roots go inside. The square roots would be x for the first spots and 1 for the second spots. One's a plus, one's a minus. You are now finished. All right, so we will talk about these more in class and bring any questions with you.